The general addition rule. The general addition rule states that if A and B are two events of an experiment, i.e. A and B are both subsets of the sample space S, then the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Or in words, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. This formula must be learnt off as it is not in the formula book, and it is a very common formula in probability. Two cards are chosen at random from a standard pack of 52 cards. What is the probability that we get either two hearts or exactly one king? Getting two hearts and exactly one king are not mutually exclusive. The two cards could be the King of Hearts and the Four of Hearts. Then we have the option of trying to list and count all the outcomes in the event. This would be too tedious, so too long, so we will use the general addition rule. Let A be the event of getting two hearts, and let B be the event of getting exactly one king. We want to find the probability of A or B, i.e. the probability of A union B. So let's start with stating our experiment. Our experiment is to choose two from 52 cards. So we're told that two cards were chosen from a pack of 52. So n is equal to 52 choose 2, which is 1,326. So event A is that we choose 2 from 13 hearts. So we were not told in the question that it's to choose 2 from 13. 13 was never mentioned in the question, but you should know off by heart that there are 13 hearts in a standard pack of cards. So we were asked for the probability that we get 2 hearts, so it's 2 out of 13 hearts, so OR is going to be equal to 13 choose 2, which is 78. Then the probability of event A is going to be 78 over 1,326, which simplifies to 1 over 17. Event B is that we get exactly one king. So that means choose 1 from 4 kings and 1 from 48 other cards. Because remember, we're asked to choose 2 cards. Again, you have to know off by heart that there are 4 kings in a standard pack. So we need to choose 1 from 4 kings, which is 4 choose 1, and, which means multiply, 1 from the 48 other cards. So 52 minus 4 is 48, so there's 48 cards left over that are not king. So that's 48 choose 1. So OR is going to be 192. Remember, and means multiply. So then the probability of B is going to be 192 over 1,326, which simplifies to 32 over 221. So now we have the probability of A and the probability of B. So remember, getting 2 hearts and exactly 1 king are not mutually exclusive. So therefore, we'll have to use our formula, which is the addition formula, which states that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So we found the probability of A, we found the probability of B, now we just need to find the probability of A and B. So the probability of A and B. So the event is choose 2 hearts to include exactly 1 king. So that means choose the King of Hearts and 1 from 12 other hearts. Remember, there's 13 hearts in a pack. So OR is going to be 1 choose 1, which is just 1, and, which means multiply, 12 choose 1, and 1 times 12 is 12. So OR is 12. So the probability of A intersection B, or A and B, is 12 over 1326, which simplifies to 2 over 222. So using the general addition rule, the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Or you could say the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So the probability of A is 1 over 17 plus the probability of B, which is 32 over 222, minus the probability of A intersection B, or A and B, which is 2 over 222. And that leaves us with 43 over 222. So the probability that we get either 2 hearts or exactly 1 king is 43 over 221. Example 2. E and F are 2 events of an experiment. The probability of the complement of E union F is 0.39. Part 1. What is the probability of E union F, i.e. the probability of E union F, or you could say E or F? Explain. So as S, which is the sample space, is equal to E union F union E union F complement, and these sets are disjoint by Axiom 3. So remember, Axiom 3 states that if A and B are mutually exclusive events, then the probability of A union B is equal to the probability of A plus the probability of B. So basically, the probability of the sample space is equal to the probability of E union F plus the probability of the complement of E union F. So this comes from this axiom here. The probability of the sample space is always 1. And we were told in the question that the probability of E union F complement is 0.39. So we swap this for 0.39. And we know that the probability of S is equal to 1 by Axiom 2. Then we just rearrange the equation. So basically bring the 0.39 over the equal sign. So it becomes a minus 0.39. So the probability of E union F is 1 minus 0.39, which is 0.61. So remember, in maths, 2 sets are said to be disjoint if they have no element in common. Equivalently, disjoint sets are sets whose intersection is the empty set. So here's an example of A and B that are not intersecting, so they are disjoint sets. Part 2. If the probability of E is equal to 0.45 and the probability of F is equal to 0.36, find the probability of E intersection F, i.e. the probability that both E and F occur. So by the general addition rule, which states that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So we have the probability of E union F is equal to the probability of E plus the probability of F minus the probability of E intersection F. We know that the probability of E union F is 0.61. We got this from part 1. We're told in the question the probability of E is 0.45. We're also told the probability of F is 0.36. And we're trying to find the probability of E intersection F. So we're going to bring minus the probability of E intersection F over the equal sign to get positive the probability of E intersection F. We still have plus 0.61, and then 0.45 plus 0.36 is 0.81. Next we bring the 0.61 over the equal sign, it becomes minus 0.61, and 0.81 minus 0.61 is 0.2. So the probability of E intersection F is 0.2. Or we can see it in a Venn diagram. We let X be equal to the probability of E intersection F. So So we have x in the intersection. We know that the probability of E is 0.545. So the probability of E less F is going to be 0.45 minus x. And the probability of F less E is going to be 0.36 minus x. Thus, the probability of the sample space is equal to 1. So what's inside the rectangle, the universal set, is our sample space. So we have 0.45 minus x plus x plus 0.36 minus x plus 0.39, which is the complement. And this is all equal to 1. 0.45 plus 0.36 plus 0.39 gives us 1.2. Minus x plus x will cancel. And we'll be left with x. And that's all equal to 1. So solving for x, we get 1.2 minus 1, which is 0.2. So again, x is equal to 0.2. So the probability of E intersection F is equal to 0.2. And this is the probability that both E and F occur.